All right, so today we're going to be doing some operations with polynomials. Okay, poly coming from the Greek word meaning many, nomials meaning terms. Okay, so it's going to be a lot of different terms. Now, with your like terms, a lot of these are going to be the same variable with the same power. I like to think of them like jerseys or uniforms for teams. Okay, um, and it's I could get some counter examples or something like that if I was a good teacher, but I'm not. So I'm just going to give you the definition and then we're going to actually start using it. Okay. So if you hear me say, jerseys or teams, I've actually had students that they do stuff like they like vampires and werewolves and zombies, and that's how they made it stick with them in their head. Just whatever you need to do to make it work. Okay. So basically, wrong place. This is the main thing that you need to have written down. Okay. That it's the same variable with the same power. The other thing is just a little helpful hint. Now, you may have seen some of this stuff before with combining like terms and stuff. We had this in Unit 1, but now we're going to have multiple things. Okay. And I had stuff like this when I was in college, and it was so bad that professor made us turn our notebook paper sideways to write the problem because that's how long it was. And we would have like 20 to 30 different terms, and we'd have to combine those. All right. Now, if we look at example 1, when we're doing this, we need to have them in standard form, highest exponent to smallest exponent. So I'm going to find all my x squareds first. Okay, some people have to rewrite it like this, and I'll do this for a couple of them. Okay, so that way we know those are the ones that we have to combine. All right, and then since that's the squared, I'm going to make a lightning bolt for mine to the first power. And I usually like to underline my constants, our numbers without variables. Okay, now, with this right here, if you have to regroup them, that's how you would do this. And then you would start, you can't put the variables in the calculator, but you can put the coefficients. Those are the numbers. Well, 5 minus 3 is going to be 2x squared. Negative 3 plus 6 is going to be plus 3x. And then 4 minus 3 is just 1. Okay, so this is our final answer. All right. Remember, it's supposed to go from the highest exponent to the smallest exponent. The exponents are the small little numbers. Okay, the small little numbers. I need to put my face somewhere. I'll put it right here. Okay. All right. On this one, number 2, looks like, what's the highest exponent we see? Awesome, to the 4th. I'm so glad everybody said that out loud. All right, so if this is to the 4th, what's our next one? Great, to the 3rd. Okay. All right, do we have any x squareds? Oh, that third power is kind of bad. Looks like we don't have any x squareds. So now I'm going to go put a box over my y's to the first. All right, and then we just start combining terms from here now that we've got them kind of grouped together. Again, a lot of people can do this without rewriting it. It just takes extra practice. I can do it without rewriting it. that doesn't say much because I'm a math teacher. I should be able to do that. But sometimes when it gets to look like a really big problem, I have to write it all out myself because I can't take all that in at once, okay? So it looks like we have negative y to the fourth plus 2y to the third minus y minus 4, okay? So just kind of the same process, just so you don't kind of like mix things together. And what a lot of people do is they forget the rules of the exponents and they try to like add and subtract the exponents. Remember, you only add exponents when you multiply. Okay? You only add the exponents when you multiply. Let's see if I can do that. Oh, that's not even better. All right. So now you can use your own symbols. I'll just start like using dots and lightning bolts and squares, just whatever. I do have lots of students that they like to write it out, or if they have it on their notes, they use a different highlighter for things just to help them. I mean, sometimes their paper looks like a bag of Skittles threw up on it, but they actually get them right every time. All right, looks like to the fourth is our own. So we only have one of those. That's pretty cool. No x to the thirds. Looks like we got an x squared. Got two of those. Minus x squared. Plus 3x. Minus 2. Plus 4. All right. Well, this is pretty easy right here. Now, what happens to our x squared terms? Awesome. They cancel out. So glad y'all are so helpful with this today. By the way, they're not. Nobody's saying anything. It's like a museum in here. I'm whispering to the people watching on YouTube. All right. This one's fairly easy. We only have these two different terms. 2 plus 4, 6. 3 plus 9 is 12. Okay. I have had people try to tell me that that's 18xy. You can't do that with add and subtract. Okay, two different teams. You can when you multiply, okay, but not when you add and subtract. All right. Now, Sarah asked if we were doing anything important today, and I said, yes, it's math. We are. But if you can add, subtract, and multiply, you can do everything we're doing in this unit. Okay. That's really the extent of the mathematical background that you need for this. Okay. Now, so when you subtract polynomials, you can do the following. You can distribute the negative and add. I just finished something, or I did something with my Algebra 2 class with this on Monday. And I had another class in the spring that they said that when they distribute the negative, it confuses them. So, and it's 6 of one, half dozen of another. Just whatever you need to do to for you to understand. Okay. But now those words don't make a whole lot of sense until we actually start using it. All right. So luckily, if we look at like number 5, they're already in standard form. Now, this distributing the negative, the way you do this is you change this to a positive, and then you change all these signs inside, because it's like multiplying it by -1. Okay, that's what it means by distributing negative. Now, you don't have to do that. Some people can sit there and they do this. They can say like 4 minus -2. Okay, but for me, it kind of helps me because I'm a little weird. But so now we have, yeah, just a little, just I'm picking one. Okay, so 4 plus 2, we have 6x cubed. -3 minus 1, so we have -4x squared. No other x terms, so plus 6x. Then -4 plus 2, -2. All right. And I didn't rewrite them. I didn't use my symbols or anything because it's already in standard form. All right. Since it's in standard form like this, it kind of makes things a little bit easier. All right. Number 6, I'm going to go ahead and distribute this negative here. So this becomes a positive. It's now -7, positive y, and -12y. All right. Looks like we don't have any other y to the thirds. No other to the second power. We do have these with y, so that's 8 minus 12, so that's minus 4y. And 10 minus 7, or -10 minus 7, -17. All right. So it's all on how you want to proceed. Okay. What's going to work for me is not going to work for this person or that person. And, you might learn something on another website, video, or whatever that makes more sense. By all means, use that resource. Okay. I'm really big on y'all finding what works for y'all and sticking with it. Okay. Notice I said what works. All right. Let's look at this one. Now, I can do this one without distributing the negative. Okay. Watch this. So those are, so I'm going to have -8, a to the 4th, minus -a to the 4th. I'm going to have a 2ab minus 4ab. Bless you. And just a minus b because there's no other ones. Okay. Now, I didn't distribute the negative, but I did have to say like this minus whatever that is. This minus whatever that is. If that works for you, that works for you. Okay. Well, minus negative becomes plus positive. So this is negative, wrong color. -7, a to the 4th, minus 2ab, minus b. Okay. This one I can do the same way without, so 4x to the 3rd minus 4x to the 3rd minus 4x minus 4x, and 2 minus 2. Well, these cancel. That's awesome. I have -8x, and these cancel. So all that just ends up like that. Is that tilted too far one way? Need to go back that way some. But it looks like it's cattywampus. I know it's not sitting straight. It's sitting like that. Might be just at the angle I'm at. There's really not a bad angle. I mean, I can, minus the glare, I can see that pretty good all the way over here. All right. So now we're going to multiply by a monomial. Okay, this is a big part of what we're going to be doing next week. Okay. So again, I like to do numbers first. So 3 times 2 is 6. Now, what do I do with the exponents this time? Add them. Yes, I actually got somebody to answer. All right. Then we have 3 times -5, so that's -15, and then we just tag this along. Okay. Again, this is a big thing of what we're doing next week, because we're going to be doing this part like number 9 and stuff like we did in the other problems. Okay. This becomes -6y to the third minus 12y squared, and then plus 30y. Almost forgot the squared. Okay. So it's kind of similar to what we did in some of our past stuff. Okay. This one, let's see, that's y to the first, so that's 3y squared plus 2y. I had a professor that would count off if your exponents weren't written just so in college. They have to be exactly 1/4 of the size and up at the top. Huh? Well, all right. And we add the exponents, so this is 4 plus 8x to the third minus 16 x squared. All right. Oh, ruh-roh, Raggy. All right. So Shaggy and Scooby are working on an algebra 2 problem. Is either of them correct? Now, the funny thing about this whole thing is that we have Shaggy and Scooby supposedly doing algebra 2 work. This top is actually an algebra 2. I would have never thought that those two people from like the original things like would actually do algebra 2. They look like kind of stoners. All right. Who's right? Is it Shaggy or Scooby? Scooby. Scooby's correct. Yeah, that is sad that the dog is smarter than him. But Great Danes are actually very intelligent. They just have a very short attention span. Now, this is where Shaggy went wrong. He distributed this right. That's correct. Okay. And he said 2 times 4. Yes. He did not add the exponents right here. This should be x to the third. So that made the wrong exponent here. So then he messed up again and then combined. Ruh-roh, Raggy. All right, we're going to come back to this in just a little bit. I'm going to let y'all try these in class. We're going to stop recording because that's kind of done with the lesson. And I'm not going to sit here for 20 minutes with dead air as y'all do these 4 problems.